Hi, my name is Michael Cole, and I'm an 11th grade student at Chaminade High School, and this is my research presentation on an in vitro study, immune signaling under metabolic stress. Now, we all know that cancer is a major problem in society, and the treatment methods we have right now, things like chemotherapy and radiation therapy, harm healthy cells alongside the cancer. Now, the question becomes, how do we find a treatment that targets the cancer specifically without doing that collateral damage? So the approach I took was to put cancer cells under metabolic stress by first cutting off their resources that they need to survive. And we did this in two different ways. The first was serum starvation, where we removed fetal bovine serum from the cell culture, essentially a mixture of growth factors the cells depend on. Now, how this is relevant to us is that we have these things called epidermal growth factors and insulin growth factors, as you can see on the image on the left. Now, the second method is glutaminase inhibition using CB839, already in phase 2 clinical trials and available as an oral tablet. We hypothesized that our two cell lines, MV411, an acute myeloid leukemia line, and DU145, a prostate carcinoma line, would respond differently to CB839 due to differences in metabolic flexibility, and that PDL1 expression, which I'll get into later, would track with metabolic state across both conditions. When we removed fetal bovine serum, viability dropped in both cell lines, but serum starvation isn't clinically viable. You can't deprive a human body of its own growth factors, so it would serve as a baseline and not a treatment strategy. When we applied CB839 to our two cell lines, MV411 and DU145 saw very different responses. DU145 progressively collapsed over time, and MV411 initially dropped but then stabilized and recovered. Flow cytometry also confirmed this. DU145 showed G1 arrest, while MV411 maintained normal cell cycle activity. From this, CB839 is doing serious damage to DU145, but it only eliminates a portion of the cells. There is still a small surviving population. So now the research focus will shift. Can the immune system handle what the treatment could not? That's where PDL1 or programmed death ligand 1 comes in. PDL1 is a protein on the surface of cancer cells that masks their identity from cytotoxic T cells, which are the immune system's main weapon. In DU145, PDL1 levels decreased over time under CB839. That surviving population was now losing their ability to hide, making them vulnerable to the immune system. So the treatment and the immune response worked together to address what neither of them could do alone. In MV411, however, PDL1 rebounded over time and viability stabilized as well. Those cells were switching from their primary energy pathway to glycolysis, keeping them alive and recovering immune evasion. Findings were then validated via a Western blot and across 20 external cell lines. In conclusion, both parts of our hypothesis were strongly supported. DU145 showed the metabolic collapse, and PDL1 decline we predicted, while MV411 adapted and rebounded, confirming that metabolic flexibility drives the divergent responses. Now, future work will use siRNA to knock down the KMT2A AFF1 fusion gene in MV411 and apply standard monotherapy, eliminating the resistance mechanism driving that adaptation. Here are my references. Thank you and have a great day.